Hi. Now, the third case of integer programming is binary variables. In this section, we will demonstrate how 0 or 1 decision variables can be used to model several diverse situations. Typically, a 0, 1 decision variable is assigned a value of 0 if a certain condition is not met, and 1 if the condition is met. Another name for a 0 to 1 decision variable is a binary variable. A common problem of this type, the assignment problem, involves deciding which individuals to assign to a set of jobs. In this assignment problem, a value of 1 indicates a person is assigned to a specific job, and a value of 0 indicates the assignment was not made. We present other types of 0 to 1 problems to show the wide applicability of this modeling technique. Let's take a look at this Cuomo Capital Company. This company is considering three possible improvement projects: catalytic converter and software warehouse expansion. Capital requirements and budget limitations in the next 2 years prevent the firm from undertaking all of these initiatives at this time. The net present value, the future value, discounted back to the present time of each project, the capital requirements for each project, and the available funds for the next 2 years are given in this table. And the available funds, if they have money, they can invest on all of these projects. However, the availability of funds is $20,000 for year one and $16,000 for year two. So as a result, they have to make a choice. To formulate this as an integer programming problem, we identify the objective function and constraints as follows. First, let's say, x1. x1 is when we invest in catalytic converter. At the time, we are going to have it 1, and if we don't use it, then it's 0. So that's binary variable for x1. For x2, software. Are we going to buy and install this software or not? So that's 1 or 0. And warehouse expansion, to do it or not, that's 1 or 0. If you have done that, now we can formulate the maximizing the net present value of these initiatives and investment. And it says the net present value is $25,000 for catalytic converter, and $18,000 for software, and warehouse expansion is about $32,000. And we have also two constraints. The first constraint is that you have to spend about $8,000 for year one for the first option, and for second option, $7,000 for year two. And if you look at just this year one column, $8,000 for first year and $6,000 for software and $12,000 for warehouse expansion. And the total investment cannot exceed $20,000. Similarly, year two is you have to spend $7,000 for catalytic converter and $4,000 for software, $8,000 for warehouse expansion, and it cannot exceed $16,000. So those are specified here, and you are now required to run Excel solver to find the answer. So here is what I did, and we can see how I ran this Excel solver. So I set up objective function and constraints as I did before. We have three variables for those three projects, and we have coefficient for their net present value of their investment, and we have this maximize the profit, and then I just entered all these coefficient that corresponded to the project, and left hand side and sign and right hand side, those are here. And you have to now go to solver if you did that and specify that your is right here, L7, and this is maximization of the profit. And then the changing variables are L4 to N4, this yellow highlighted area. And then we have to add constraints. So these two constraints are easy. You just need to put this left-hand side and right-hand side. But one thing that you need to do is that you have to make sure that x1, x2, x3 are all binary variables. In other words, they are 0 or 1. That has to be is indicated. So I put them and then I indicated that they are binary variable. And then you ran it, then you will get x1 is 1, x2 is 0, and x3 is 1. And I'm going to show you shortly how I did it.